wonderful class. I like them very much, but they have no hope in heaven of solving this question, okay? And they need to, very badly. So the question was 4 equals 8. Sine to theta minus 20 plus 1, that is? Now, the thing is, you will need to solve these in advanced functions in calculus. People get lazy and they try and do shortcuts, okay? Don't do shortcuts. I'm not kidding, because it makes big problems in the future with them for you, okay? So, because that's how they learn shortcuts and they forget how to do this when you actually need to solve a question involving sine and cos. Can someone be brave and give me the first step? Go ahead, Quinn. Good. Okay, so that turns into 3 equals 8 sine 2 theta minus 20. Very good. Can someone give me the next step, please? Yeah, go ahead. Divide both sides by 8. Good. So that's going to be 3 over 8. If you want to call that 0.375, you may. I know it was a fraction because I'm a math teacher. Can I get another person to give me the third step, please? Oh, and go. Sine first 3. Good. Oh. Equals 2. Come on in. Come on in. What's that? Just wait 1 sec. Because you're being recorded right now, so you probably don't want to be recorded. So back to this here then now. Can somebody please use the power of their calculator and tell me please what sine inverse of 3/8 is, please? Yeah, go ahead. 22.02. Someone can confirm that for me, I hope? Yeah. Okay, I'm going to go to a second board right now. Can somebody tell me why I went to the second board? Yeah, go ahead, Alana.
Because you're going to do 180 minus 2.2.
Very good. Now remember, this happens as soon as you do sine inverse. This is the part right here that my calculus students forget about right at this moment, okay? Because what they try and do is they try and cheat like some people have been trying to do, okay, right? So, and it doesn't work for them, okay? So as soon as you do sine inverse, that's when it's going to start. Okay, can someone be brave and solve for theta all the way down the left side here, please? Yeah, Lena, go ahead. Good. Yeah. So that is 31.41. Okay, that is in our domain, so life is good. Can someone please continue? What else can we do? Okay, please.
180 plus 31.9.
Good. Now, that's correct. Why did you add 180?
Because the period is 16.2.
Very good. Excellent. Good explanation.
Wait, can you
You're going to add whatever the period is. Now, the period, remember, is going to be 360 divided by whatever that number is before the brackets. So it's going to be 180. Yeah. Nine divided by 2. Okay, I do. Yeah. Okay. Okay, so those are the next ones. That'll be it, because if I add 180 again, that's going to be 391.1, which is too big, right? You only want to go from 0 to 360. Okay, great. Can someone do the same thing on the right-hand side, please? Somebody new. Please, somebody new. Come on, play along. Oh, Tristan, wonderful. Go.
All right. That's 157.97.
Very good.
Equals 2 direct theta minus.
Okay, keep going.
78.
Yeah.
0.98.
What is it?
Calculator's a little off there.
Can't do it. 78 point.
Yeah.
49?
49.
Is it 49 or 99? Yeah, obviously.
Theta minus 20.
Yeah.
98.
Oh, goodness. Tristan, I'm glad you volunteered. Thank you. Okay.
Add that period.
Thank you.
Add that period.
Okay, and that's 278.99, is that right? Okay, there we go. All right. Okay, please, can you give me your phone, please? Give a calculator in front of you. Why do I say game with guests? Don't do that. Seems ridiculous. Okay, let's get started here, please, on today's lesson. So this is going to be a little mini note here. This is on graphing reciprocal functions continued. When I was helping people at the end of class, yesterday, I looked at their graphs, and there was way too much stuff happening there, okay? When you graph the original function and the reciprocal, it's hard to see what was going on. Because of that, what I did for you is I went to my favorite website, diagonals.com. Did everyone get one of these? Spell that. DESMLS.com. And what it does, it will give you beautiful graphs like this, okay? So what I've done is I have graphed the original function. What we're going to do in today's lesson is we're going to graph the reciprocal. Okay, so just a reminder, because these are things you need to know. To graph a reciprocal, okay, can somebody think back to yesterday? Give me a few points to what we used to graph reciprocal. Go ahead.
Everywhere,
Okay. The 0 for the regular graph. Because,
So first you have to sketch it.
right on. Number 1 is sketch the original. Okay, and it's done for you today already. But without the regular graph, it's impossible to do. Okay. All right. What else? There's some other things I can do here for the reciprocal. What else can I use? Yeah. Okay. So we're going to say when the original graph is at 1, we're going to say shared points at y equals 1 and y equals -1. The reason for that is when y equals 1, 1 over 1, that's the reciprocal, is still equal to 1. When y equals -1, that's 1 over -1, which is still -1. And the last one I'm going to put on here is use your max or min to make a point 1 over max. And we'll get to that in a sec, okay? So what that meant from yesterday was, remember our graph went up to 5, so we did a point at 1/5. Okay, we had a point at -3, so then our other point was -1 over 3. And we'll go into these. Sorry if you're sitting at the back and you can't see my poor printing. Okay, 4 use your max min. Hopefully in advanced functions you guys will have like 18 kids in your class next year, and you'll be able to see quite well. No, there's actually 3 courses this year, so they'll probably be small. We have 3 advanced functions classes, I think, and 2 calculus. So nobody knows. Okay, I'm going to hit pause for a sec. I'm going to hit stop for a sec, actually. Look at this thing. Okay, just wait. I'm going to stop this and save.